Right now, as you watch this, there are 2 trillion galaxies in the observable universe. Each galaxy contains an average of 100 billion stars, and around those stars orbit hundreds of billions of planets. Scientists estimate that there are more potentially habitable planets in the universe than grains of sand on every beach on Earth. And in all of that, we have found zero evidence of anyone else. Not a signal, not an artifact, not a shadow, not a single confirmed biosignature anywhere. Zero. That is what is known as the Fermi's Paradox. And once you understand it, you really truly understand it, you'll never look at the night sky the same way again, and it may disturb you. In the 1950s in New Mexico, a group of the most brilliant physicists on the planet had lunch together. One of their names was Enrico Fermi, and he won the Nobel Prize in physics. He built the world's first nuclear reactor, and he's widely considered one of the most intelligent humans who ever lived. Sitting at that lunch table, fork in his hand, he suddenly looks up in the sky and asks the question so simple it sounds almost childish. Where is everybody? His colleagues knew exactly what he meant. If the universe is this vast, if it existed for 13.8 billion years, if the conditions for life exist on millions of billions of worlds, why is there no evidence of anyone else out there? Why no signals? Why no visitors? Why no megastructures visible across the galaxy? Why no ruins? Why no echoes? Fermi ran the numbers and in his head at the table and concluded that statistically speaking, aliens just shouldn't exist. They should be everywhere. They should have been here millions of years ago. The contrast between the mathematical expectation and the total silence we observe is what we now call the Fermi's Paradox. He asked this question in the 1950s, and we've been unable to answer it since. In 1977, an astronomer named Jerry Ehman was reviewing data from Ohio State University's Big Ear Radio Telescope, part of an early search for extraterrestrial signals. He was going through printouts, pages and pages of radio frequency data, mostly noise, mostly nothing. And then he saw it. A signal. A narrow band radio transmission coming from the direction of the Sagittarius constellation. It lasted exactly 72 seconds. The maximum the telescope could track before the Earth's rotation moved it out of range. The signal was so precise that scientists predicted alien contact would look like. The right frequency, the right bandwidth, the right intensity, appearing and disappearing in exactly the right pattern. That Ehman grabbed his red pen and wrote one word in the margin of the printout. Wow. That document still exists. You can look at it right now. Scientists have pointed every available telescope to that region of the sky hundreds of times since 1977. They've used more powerful equipment, longer observation windows, different frequencies. The signal has never been detected again, not once in over 50 years. We have one data point that could be everything, and we cannot find it again. It's eerily disturbing. Scientists and philosophers have proposed dozens of solutions to the Fermi's Paradox. Hold on to your butts because this may be a little bit scary. Solution 1 is what is known as the Great Filter. The Great Filter theory says that somewhere between dead chemistry and galaxy-spanning civilizations there is a barrier, a filter, that almost nothing gets through, something that kills civilizations or prevents them from ever developing. We just don't know what it is. But here's the critical question. Have we already passed it, or is it still ahead of us? If the filter is behind us, if it's something rare that we already survived, like the development of complex cells or multicellular life or human-level intelligence, then we may be genuinely the only first civilizations to get this far. The silence would make sense. We're early. But if the filter is ahead of us, every civilization that reaches our level eventually destroys itself through nuclear war, engineered pandemics, artificial intelligence, climate collapse, or something that we haven't even imagined yet. Then the silence isn't just a mystery, it's a warning. Every quiet star is a civilization that didn't make it. The second solution is known as the dark forest. The dark forest theory comes from a Chinese science fiction author, Lian Qian. It is perhaps the most chilling solution ever proposed. The theory states that the universe is a dark forest. Every civilization is a hunter moving silently through the trees. Because resources are finite, you can never fully trust another civilization's intentions, and the only rational strategy is to destroy any civilization you detect before it can destroy you. In this model, broadcasting your existence isn't communication, it's suicide. We've been sending radio signals into space since the 1930s. Our broadcasts have now been reached tens of thousands of star systems. If the dark forest is real, we announced ourselves to the forest decades ago, and we're still waiting to see if anything is heard. Solution 3, the zoo hypothesis. This hypothesis proposes something almost comforting until you think about it too long. What if we're already here? What if advanced civilizations are watching Earth the same way we observe animals in a nature reserve, with strict non-interference policy? What if there's a galactic consensus, a rule agreed upon every advanced civilization, that primitive species like us are left alone until we reach a certain threshold of development? What does that threshold look like? We don't know. Have we reached it? We don't know. Are they watching us right now? We have no way to tell. The zoo hypothesis means that silence is an absence, it's a boundary, and we don't know where it ends. And finally, solution 4, we are first. And then there's the solution that carries the most weight of it all. What if nobody is out there? Not because they were destroyed, not because they were hiding, but because we are genuinely, cosmically, incomprehensibly first. The universe spent its first several billion years too metal poor to support a rocky planet capable of complex life. Earth formed at what some scientists call the earliest possible window for a civilization like ours to develop. What if we're not late to the party? What if we're so early that the party hasn't even started yet? What if the universe is 13.8 billion years old, and we are among the first intelligent species to open our eyes in it? That means that silence isn't frightening, it's a blank page. It means everything that intelligence will ever do in this universe, every civilization, every discovery, every story told across the cosmos hasn't happened yet. And here we are at the beginning of all of it. This is what I really want you guys to think about. The Fermi's Paradox isn't just a science question, it is a mirror. If the great filter is behind us, we are extraordinarily lucky and we carry a responsibility to survive that almost nothing else has. The great filter is ahead of us. Every decision our civilization makes right now is potentially a decision between joining the silence or breaking it. And if the dark forest is real, the universe rewards caution, silence, and survival above all else. And if we're first, well, then the entire future of intelligent life in the cosmos may be seeded by what we do next. Every answer to Fermi's question says the same thing in a different way. What you and I do with the time that we have matters more than we think. Enrico Fermi asked one question over lunch he probably forgot about dinner time. And that question has consumed physicists, astronomers, philosophers, and writers for over 75 years. We've built telescopes the size of football fields. We have pointed them at millions of stars. We have sent probes to the edge of the solar system. We have decoded the cosmic background radiation left from the birth of the universe itself. And the answer to where is everybody remains what it was at that lunch table in the 1950s. We don't know, but we are still listening.